So after yesterday's sort of video, I decided that basically there was a way more efficient way than using a cellular sort of map. It is a bit more complicated, but it actually creates probably better biome realism when it comes to the actual appearance of what happens in the game. So basically, this is called a Whittaker's classification of biomes, and basically this sort of map determines what a biome is depending on the precipitation and temperature. Now, to derive precipitation and temperature, all you actually need is going to be a Perlin noise. So you'd run one noise for this and one noise for that, and then you'll be good. This is actually going to end up being faster, since it takes about 80 milliseconds to generate a cellular map, whereas it would take 40 seconds to generate two. Now, what was also interesting is that you can skip some of the way that biomes work based upon altitude map. So you run a one level altitude, and this will figure out what is ocean, what is the what would you call it, the beach, and then what is the landmass, and then only on the ones that are landmass do you have to actually run this. So I found an old post actually from Minecraft Alpha, and this guy went ahead and actually figured out a lot of how the code sort of worked for creating these sort of maps. And in general, he came up with basically this one chart that determines what everything is. Now, first, actually we're going to change something with the noise settings, because I remember that I created an amplitude field here and thought that it would be useless, because it kind of was. But to generate the base layer, I decided that you're going to have to generate the base layer and then generate a layer on top of that. And in order to do that, we would actually have a base amplitude for everything. So settings dot amplitude, and then let me check where that was in the position here. It's the second position, so right after the number of octaves, the initial can be 1.0f. So that's how you can get a get noise function with a certain settings. Now, after we generate this first base layer, we can go ahead and do something like this. And then to generate biomes, we can go ahead and do for, and then if map at x times 128 plus y is less than 0.5f, we can go ahead and say that our biome at the same value is actually going to be equal to like an ocean. Now, that doesn't mean anything, does it? So we're going to change the way that the biome maps from being a floating point integer to being, from being a floating point to being an integer of unit 8t. This actually decreases the total size that we actually need here, and it's way more nicer to have, so unit 8 underscore t. What this also means is that we can create an enum. So given all of these different types of biomes, each one has its own value, so we can go ahead and say we have now created biome types, and the biome map will then use biome type, biome ocean. Basically, we've generated the base layer. We can range map this later. But then we can also then do, this generates the biome map, and then we can do add Perlin worms, and then add the terrain layer. And if we did something like this, let's go ahead and say that now, if it isn't one of these two cases, now we do the expensive operation. So the expensive operation is generate a temperature, then generate precipitation. So then we would want float temperature equals generate noise. And x and y are integers here, so static cast to float. And that creates that generate noise for the temperature, and then we can do the exact same thing here for the precipitation, and instead we'll do like times 7 or something. And maybe, honestly, let's do it like division, because division is probably more, it creates larger maps. So then we'll say biome map at index equals biome get biome from temperature and precipitation. And then alright, so for here, for the getting the biome, we can create some pretty simple rules. So if the biome, if the temperature is less than, let's say, 0.3, and now I know that this isn't necessarily true. It would actually be plus or minus standard deviation from the center point 0.5 for figuring this out, but for now, it is fine. Because typically what we would have would be a normalized binomial distribution. Or you could call it a bell curve, basically, and you would have a standard deviation up and down. But roughly, in rough terms, this is about a standard deviation. So if it's like less than this temperature, then we can go ahead and say return biome tundra. And the reason we can return just biome tundra is because, a tundra might have a lot of snow and it might not have a lot of snow. So the temperature being less than 0.3F is all just going to be tundra. So now we have plains, desert, forest, and rainforest. So else, if temperature is greater than 0.3F or greater than equal, and temperature is less than or equal to 0.7, so the hot side, then we'll just return biome underscore, we'll put another if, and then we'll determine based on precipitation. So if precipitation is less than 0.5, then this is true, else it's the other side. So we would return this being, so less than 0.5 would just be a forest, so biome forest, and then otherwise return biome or rainforest would be the other case. Now, rainforests are also more hot, but in the very basic context that this could be reasonable, right? And we don't just have to do this, so we can go ahead and do another case, else if, or I guess it would just be else, the temperature has to be greater than 0.7F here then. So now we've taken care of forest. Now, plains, if precipitation is less than 0.3F, we can go ahead and say that return biome desert, because deserts don't have much rain. Otherwise, if it's kind of an average amount, so 0.3F2, and precision is less than or equal to 0.7F, then we could do return biome plains, and then otherwise we can return the biome rainforest as well. So that will have a little bit more rainforest presence in the world. Else we would just return like -1 or something, because it has to be fulfilled within this sort of structure. So now we have a biome type, and now we can use this in order to be able to visualize it. Now that it runs, it creates this really weird map, and the reason it creates this really weird map is probably almost certainly to deal with the fact that right now in the main CPP, it doesn't actually care about biomes in the correct manner. So I'm going to completely delete the thing that we just have here, and instead, now we can actually go ahead and figure out what we want the color to be based upon what the biome itself is, because now we don't even have to worry about what the map value is. We can go ahead and just display our biome mapping, because in general that will be more correct, and then we could add like a factor later on that adds or decreases from a function depending on the actual map value. So for now, for the biome value is no float, so that's the first thing to change. uint 8t actually. Biome value is the biome at the index. So then we would go ahead and run a function, which would just be get color. So gen color.c equals get get color, and then it will just have the biome value. And then depending on the biome, we can just put the value of that color in. So then we can go ahead and create auto, get color, and then it just takes uint8_t, and then it returns a uint32t. But the better option actually would be switch case on a static cast biome type B for B, and then you could go ahead and create a switch case, and you could run case biome type, or you could run case biome ocean, and then you would just do return GRGBA for this. Now, as you can kind of see, we have some sort of land mass that is formed here. It's not very detailed, it's not very intricate, but it does indeed show a biome or an area on the map where we have like this beach and everything going through it. Now, what we can add to this is going to be some more sort of depth to this by adding some sort of factoring for what the actual noise value is. So we can go ahead and say the gen color dot RGBA dot R times equals the floating point value. So floating point map val equals map at index, and now we can do times equals the map value, because the map value is guaranteed to be between 0 and 1. So R, G, B, don't want to change the A value actually, so just have it increase or sort of be a little bit deeper. Yeah. And then that should go ahead and make it a little bit more interesting. You'll start to see a little bit more detail on the map than just what the biome is. So if I reset. Alright, now as you can see, it is a bit darker, but it does kind of show what it sort of looks like in general. And now what we can do is that we can go ahead and run actual noise on top of that. So now that we generate the base layer in the biome map, we can go ahead and modify the terrain and make it have different settings depending on what biome it is. So we can go ahead and do... So for our noise settings thing here, I think we'll just create a static noise settings array of size however many biomes we have. How many biomes do we have? We have 8 biomes, so a noise settings object of size 8, and then we can set that statically to be equivalent to something. 8 equals that, and then we return noise settings at biome. And that... Oh wait, sorry. We have to return a address, so it's a pointer, and then we should be able to go ahead and fill that out. Now that shouldn't necessarily fail, but it's not going to generate anything valid because we don't have valid settings here. And now once I create some valid settings here, then we can go ahead and get on with it. I'm also going to add an offset here just in case you want something to be offset by a particular amount. So one thing for biomes that I noticed wasn't going correctly is this, because this is an integral division, and what we wanted was floating point division, so it should actually be this code instead, because this actually creates what those really weird sort of patterns look like. So now if you do this, the biome borders will be a lot smoother if you just go ahead and do floating point division. It has way better sort of look. So with a bit of tinkering to what the world generation algorithm sort of looks like, we end up creating something pretty interesting. So if we go ahead and go to the BMP file, this is the most recent sort of iteration. Now you'll see that we've actually created a sort of map here that looks pretty good. There's some deserts going on around the edges here. Or not deserts, sorry, beaches going around the edges, and you can see that certain biomes are overlapping here. This darker green one, I believe, is sort of the normal forest, and these are more of the rainforests. There's quite a bit of balancing that we can do, but this ends up looking pretty nice in my opinion for overall smooth sort of creations of these different biome maps. I'll work a little bit more on this to get it to look a little bit better and have a little bit more biome diversity. So after a bit of testing here, this is one of the maps that we were able to generate. So as you can see, there's quite a bit of ocean. There's like a decent amount of ocean, and these oceans are actually generating these sort of islands now. And previously, the way that the function would generate, you would create these solid land masses, but now you actually have these like little, I don't know, lakes and bays and things like that that are sort of encapsulated due to adding a little bit of extra noise to the function. You're also creating a lot of these different sort of generation areas. The gray areas are these tundra biomes, these really snowy, cold biomes, whereas you have more common like forests being these greens, and then you have this desert, which is this really nice little orange color here. And while there isn't much desert around this area, deserts do start to show up in some different parts of the maps, and depending on the general area, whether or not it's hot or cold, you can see a lot more of these sort of pop up across these larger areas of the map. So I think that this is a really interesting sort of concept. Down here is like a desert that will continue to go as well. But I thought this was a really interesting sort of experiment. And now it takes, now while I made this method a little bit more expensive by creating this nicer sort of generation algorithm for the oceans, by adding a second layer of noise to it, it still ends up running in about 140 milliseconds, which is pretty good when we consider that this was also, I believe it was about 140 milliseconds before, for 140 milliseconds or worse for creating the same sort of structures here using the cellular noise, but this looks way better, and it definitely improves the sort of look of the terrain in general. So for now, this is what I would consider good enough for the biome maps. And tomorrow, what I think we can work on is adding Perlin worms. These are really interesting sort of structures, and we can have one or two of them we can add a bunch of different spawn points for them seeded throughout the world, and these spawn points will then execute a Perlin worm, which iterates through a certain number of different iterations, and it would go through and carve through the sort of terrain maps around here. These sort of Perlin worms would snake across and basically create these rivers for us, and it will add a whole lot to our terrain in order for it to look a lot more realistic as well.